Here's what it looks like when we put it all together in the code. We still have an exp data type. This is the output from our parser. But the output of compile is not going to be an xd anymore because the interpreter works on xds. And so the interpreter needs to work on raw memory with these tags. So when the interpreter is given a pointer into memory, and when that points to the number 8, then we know it's pointing to a numd record. And right after that 8 in memory will be another number that's the literal number for that expression. If the interpreter sees memory that starts with 9, then it knows that it corresponds to plus d, and the next 2 bits of memory will each be a number, each of which points to another record for the left-hand side and the right-hand side expression, and so on. So we have these distinct numbers for the different atds, xds. We have distinct numbers for the different kinds of values, and distinct numbers from the different kinds of continuations. And it turns out that these 3 different sets of numbers don't need to be distinct as they are here, but it makes things simpler and easier later. So we'll just assign each variant to have a totally distinct number. Here is our memory manager. So malloc is just a little bit different than we had on the slide, but the same idea. So we have malloc1, malloc2, malloc3, malloc4, and the ref function is implemented using vector ref. So you have a base address and an offset. We just add those 2 numbers to get an index into memory to reference memory. Parse is as it was before. Compile, though, needs to use malloc to allocate numd-like things, plus d num-like things, and so on. And the compiler is allowed to be recursive, but then we get to the interpreter, which is the part we want at the machine level. And so it no longer is allocating records. It's just calling these malloc functions. And it's using case to dispatch on the number at the address that's given in the register. Right? So we've replaced all of the uses of variables from pattern matching by explicit references into memory. And the same for continuations. So now we have something that looks very much like machine code. We do some sort of case number-based dispatch, number-based jump to get to these different cases. Each one is a sequence of register uses and assignments. We have memory dereferences, and we have jumps for the interpreter. We have these things that look like function calls in terms of malloc2, malloc3, and so on, but those were all short functions, and we could in principle inline those implementations so that we get down to very basic machine code-like instructions.